In today's video, we're going to be studying ketones. Now here we have the outline of what we'll be discussing. What are ketones, isomerism, synthesis of ketones, and uses of ketones. Now ketones are organic compounds that have the carbonyl group, just like aldehydes. Okay, now the carbonyl group is the carbon atom bonded to an oxygen atom by a double bond. Now in ketones, this carbonyl group is bonded to carbon on one hand and another carbon on the other hand. Now this is its major difference to an aldehyde, because for an aldehyde, it's bonded to carbon on one hand, and instead of having carbon on this side, we have a hydrogen on that side. Now a general representation of its formula is R and with carbonyl group and R on the other hand. Now R here of course represents an alkyl group. Okay, and of course the ketones form a homologous series of compounds. Okay, so let's take a look at isomerism in ketones. For this video, we'll be considering functional isomerism. Now, ketones exhibit functional isomerism with aldehydes. And functional isomerism is simply the existence of compounds with the same molecular formula but which belong to different homologous series. Now, of course, ketones and aldehydes are separate homologous series. Okay, now there may exist a particular ketone which has a corresponding aldehyde with the same molecular formula. Now the general representation of an aldehyde is R, then we have the carbonyl group and hydrogen on the other side. Well, for the ketone, it's R and then the carbonyl group and another R on the other hand. Now R of course here represents an alkyl group. Now this is an aldehyde and this is a ketone, so I'll represent it with A and K. Okay, now take for instance the R on this side is an ethyl. Okay, and the general molecular formula for an alkyl is CnH2n plus 1. Okay, so an ethyl would have the formula C2H5 since N equals 2. So we can write it out as C2H5, of course bonded to an alkyl group, or rather bonded to the carbonyl group, hydrogen on this side. Okay. And then here we'd assume that both alkyl groups in this ketone are methyl. Okay, so assuming both alkyl groups are methyl, then we'd have methyl on one side and then the carbonyl group and methyl on the other side. Okay, now the total number of carbons that we have in this particular aldehyde, we have 2 carbons here and we have 1 carbon here. So in total we have 3 carbon atoms, so C3. Now on this side we have 5 hydrogen atoms and here we have 1 hydrogen atom. Okay, so that is 6 hydrogen atoms in total. Now of course we have 1 oxygen atom, so we have C3H6O, right? Now coming to the ketone, we have 1 carbon atom here, another carbon atom here, and another carbon atom here. So we have 3 carbon atoms in total. Now we have 3 hydrogen atoms here, 3 hydrogen atoms here, meaning that we have 6 hydrogen atoms in total, and of course we have the oxygen atom. Now notice that these two molecular formulas are identical. So it means that this aldehyde and this ketone satisfy the condition for isomerism, and the particular isomerism that they exhibit is functional isomerism. So ketones exhibit functional isomerism with aldehydes. Now let's take a look at synthesis of ketones. Ketones are synthesized by the oxidation of secondary alcohols. Okay, now in our video on aldehydes, we mentioned that oxidation in organic chemistry is simply the replacement of a carbon-hydrogen bond with a carbon-oxygen bond. Now, a secondary alcohol is an alcohol in which the hydroxyl group is bonded to a carbon atom that is bonded to two other carbon atoms. Okay, so for this example, let's take a look at 2-propanol. Now, 2-propanol can be represented with this structure. Okay, so we have 3 carbon atoms in total, and then 2 here means that the hydroxyl group is attached to the second carbon atom, and this is the second carbon atom. So we have the hydroxyl group attached here. And of course here we have hydrogen, 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 and now since oxidation is simply the replacement of a carbon-hydrogen bond with a carbon-oxygen bond. Now let's take a look at this this carbon-hydrogen bond that exists here. Okay, now what happens is this: the bond that exists between the carbon and the hydrogen is made of one electron from carbon and another electron from hydrogen. Okay, and of course here we have the hydroxyl can actually be represented in this way. So we have oxygen and then we have hydrogen in this way. Now the bond that exists between the oxygen and the hydrogen is made of one electron from the hydrogen and another electron from the oxygen. So each of these atoms retracts their individual electrons. Now the electron from the oxygen bonds with the electron from the carbon, and the carbon-oxygen double bond is formed. So we'd have a carbonyl group that looks like this. So this bond is broken and this bond is broken. Okay, so we'd have so what would form in this situation would be a ketone. Okay, so we'd have CH and a carbonyl group. Okay, and then C, H, and H. Now we can see that on either side of the carbonyl group we have an alkyl group, and in this case the alkyl group is methyl. Okay, so R, then the carbonyl group, and another R. Okay, so this is a ketone, and this ketone would have the suffix non, okay, or on. Anyways, let me add non. So since it's a 3-carbon ketone, it would have the prefix prop, and it would be named propanone. Okay, and to emphasize that the carbonyl group is on this, or rather the oxygen double bond is on the second carbon atom, it would be named 2-propanone. Okay, this is a ketone, and this is how ketones are synthesized. And this is how ketones are synthesized by the oxidation of secondary alcohols. Okay, now it's important for us to take note of the fact that ketones cannot be synthesized from tertiary alcohols. Now, what is a tertiary alcohol? A tertiary alcohol is simply an alcohol in which the hydroxyl group is attached to a carbon atom that is attached to 3 other carbon atoms. So if we have a carbon atom attached to 3 other carbon atoms, so let me highlight the tertiary carbon with red. Okay, so it also has a carbon atom here, and then we have the hydroxyl group here. Now notice that in this tertiary alcohol, we do not have a carbon-hydrogen bond. Okay, we do not have a carbon-hydrogen bond. And by implication, it means that there is no carbon-hydrogen bond to be replaced with a carbon-oxygen bond. So this particular alcohol cannot undergo oxidation, and by implication, it means that it cannot form a ketone. Okay, so it's important for us to take note of this. Now let's take a look at the uses of ketones. Now for this video, we'll be considering the use of propanone. Now propanone, as we have seen, is formed by the oxidation of 2-propanol. Okay. Now propanone has the general representation CH3 CO CH3. Okay, and it can be represented like this with the carbonyl group and CH3. Okay. Now notice that we have a methyl group on this side and another methyl group on this side, and this is a ketone. Now this can also be named dimethyl ketone, and it also has the common name acetone. Now acetone is used as a paint remover. So in cosmetic stores and cosmetic shops, people use acetone to remove nail polish or to remove nail polishes, to clean off nail polishes. So it's a solvent for nail polishes. This is just one of the many uses of ketones. Okay, so we have come to the end of this video. If you enjoyed this video, please give it a thumbs up and don't forget to subscribe.